Okay, today we'll be talking about rays and angles. We're going to start off with the notes here and work our way through some examples throughout the packet. So, in this first part, we have a ray. The ray is part of a line that has an endpoint at one end, like so, and goes on indefinitely on the other side. Another way to think about it is if it were half a line, because a line goes infinitely on both sides, whereas a ray has an endpoint like a line segment and then continues on forever in a direction like a line. The way you name a ray is with its endpoint first, so in this case the endpoint is at A, and then another point on the ray. These are not interchangeable. The first letter must be the endpoint. Okay, so some key things to highlight. I'm highlighting in yellow for these notes. I'm going to do math theorems in orange. And my pink pen here will be my clarifications. So, for vocab, I would say a ray is part of a line that goes on indefinitely to the other side. Okay? My key takeaway would be that the endpoint comes first when naming a ray. Okay? Next up, we have an angle. An angle is formed by two non-collinear rays that have a common endpoint called a vertex. So, let's clarify that the vertex is the point where the two rays of an angle meet. Okay? And non-collinear means they are not on the same line. Okay? There are two ways to name an angle. If there is no ambiguity, which means if there's only one angle, like in our picture here, then you can use the letter associated with the vertex of the angle. So if there's only one angle like our picture, then we use the vertex to name the angle. So this would be angle B. However, if there is ambiguity, meaning that there is more than one angle, then you use three letters associated with the angle and have the vertex as the middle letter. Okay? So here we have multiple angles, so we have to use the vertex as our middle letter, and then we can name all of the angles with the other two letters. Now when I name angles like ABD, for example, I'll do in orange. Okay? ABD, I put my marker on A, I follow it to B, and then I get to D. So there is my angle like so. And you can repeat that for all of the other angles. Next up, we have interior points and exterior points. Interior points obviously are on the inside of the angle, whereas exterior points are on the outside of the angle. Okay? I like to think of the angle as a big mouse. So here we have angle ABC. That is its name, angle ABC. And the points that are in the mouth are G and D, inside. And the points that are outside are F and H, because they are outside. ABC are on the angle, and so is E. If I were to extend my angle, it would hit E, so E is neither inside or outside as well. That's all the vocab for this, so take a minute and really reflect on vocab. Remember, another key takeaway is that when naming angles, and I use that symbol for angle sometimes, but I'll also write angles in parentheses here, the vertex must be the middle letter. Okay? So when naming angles, the vertex must be the middle letter. All right? Moving right along. Still keeping the theme of yellow as vocab. orange as math terms, and pink as clarifications. On this page, we're talking about an angle's classification, or how it's identified. Okay? There are 4 types, and they're identified as follows. We have acute, which means that it's between 0 and less than 90. I think of acute angles as small and adorable. That makes them very cute. So an acute angle is less than 90. Then we have a right angle, which measures exactly 90, which means that we need to add our little box here to denote that it is a 90-degree angle. Remember, the acute angle up here is named angle A by its vertex. This would be angle B because of its vertex. Okay? If we keep going, the next classification is obtuse, which measures more than 90 and less than 180. It is angle C. And lastly, we have a straight angle, which measures exactly 180 degrees. And it would be angle D. Okay? Notice that the straight angle is also a line. So, to clarify, a straight angle is also a line. For our P&A today, make sure you really pay attention to obtuse, and a key takeaway is obtuse is less than 180 degrees, but more than 90 degrees. Okay? And that is the different classifications for our angles. Remember, there's 4: acute, right, obtuse, and straight. Do not get classification confused with its name. This angle is acute. Its name is angle A. Okay? So what it is acute, but what its name is angle A. So make sure you're aware of that. All right. Next up, we should have something very familiar, which is the angle addition postulate. So the angle addition postulate is exactly a postulate used to find the measure of various angles. Okay? So just like last unit, we have our good friend, the part plus part equals whole equation again. Which is going to help us find large angles or pieces of angles depending on information given. We have our proof here. So the angle addition postulate is used to find proof. So here we were given a picture. Remember, whatever the problem is, picture, numbers, whatever, all of that is a gift, and it is therefore given to us. Then we use our equation, which is the part plus part equals whole, and we plug in our letters and things, and our variables, and we get the angle addition postulate. When we go from letters to numbers, that is substitution. And then when we simplify or we do any kind of math in order to get x by itself or algebra, we do the various properties of equality, in this case subtraction. So, before we get into this problem, I want to clarify this part right here where it says explain the difference between the measure of angle IJA and the angle of IJA. Well, if you remember last unit, we had the difference between RS and segment RS, where this was the value and this is the name. Well, it's the same thing with angles. The measure of angle IJL and angle IJL, this is the value, this is the name. So very similar to segment addition property. Okay? So we have this picture. A lot of you on the test skipped looking for what is the most important thing, and that's our goal of what to find. It says find the measure of angle IJL. So I need to say that the measure of angle IJL is currently equal to, let's find out. It says if the measure of angle IJL equals x plus 65, so we know that this guy is x plus 65. Which means that I have to solve for x before I can do anything. So I can come in here and say that IJL, so I to J to L. So this piece is X plus 65. Okay? We'll highlight them in orange to make them stand out a little more. Okay? Then it says the measure of angle LJK, so LJ and K, is X plus 107, so LJK, X plus 107. And then it says the measure of IJK, so I to J to K, so this guy, which we'll do in this color, we'll do black, is equal to 158 degrees. So if you look at this, it kind of looks like a part plus a part equals a whole. And if you notice, I highlighted my parts in one color and I did my whole in another. I know a lot of you don't like using color and don't like using our strategies, but use them. They are very valuable and they help. So if this is part plus part equals whole, if I was doing the proof, this would be the segment, or not segment, we're doing with angles. The angle addition postulate. We would then plug in our stuff. So I have X plus 65 plus X plus 107 is equal to my 158. Okay, so this would be my whole. These two guys are my parts. That would be from letters to numbers. We have substitution. Okay. We then simplify stuff by combining like terms. I end up with 2x plus 172 is equal to 158. This is combined like terms. I then subtract 172 from both sides. Remember, if I want to hop over the equal sign, I have to do the opposite in operation of what I have. My 172's cancel. I'm left with negative 14. I divide both sides by 2. But before I do that, my step before was the subtraction property of equality. And I end up with x equals negative 7 due to the division property of equality. Okay. But this is where a lot of you stopped on the test, and it didn't ask us for x, it asked us for the measure of IJL. So I need to go in and substitute that back in so that I get the measure of angle IJL equals x plus 65. Now it's going to be negative 7 plus 65, or 58 degrees. So the measure of angle IJL is 58 degrees, and that little circle there is the degree sign. And that's how you do angle addition postulate. Our last bit of notes is all about how to use a protractor. So this page tells you how to use a protractor. You can use it in two ways. Protractor looks like this. Some kids call it an angle measure thingy, but I like to call it a protractor. The way it works is as follows. We're going to do it on the next page. Feel free to read this page on your own. But here are some angles. The classification for this one is acute, so my measurement better be less than 90, but greater than 0. So what we do is we take our protractor, and this dot here, we want to put it on the vertex. And then if you see really, really close, there's a black line that goes through that dot. This is our 0 line and our 180 line. We want to line up that black line on a ray as best we can, and then we're going to read our angle. And so it appears that this is about 52. Notice that I'm using the inside numbers because this is 0, and from 0 to get to the next number, I have to use the inside because that's 10. I don't want to use the 180 because if I use the 180, then I'm going to end up getting like 128, and that's not less than 90 or greater than 0. So instead, I use the inside numbers, which puts us at like 52 degrees. We take a look at this one. It looks pretty close to a right angle, but we'll find out when we measure, which means it needs to be equal to 90 degrees. And if we check it out, we see, yes, in fact, it does equal 90 degrees. So we can put our box there and say 90 degrees. Last but not least, we have this obtuse angle. And we're here. And if we look, it's 130 degrees. Okay? There's examples on the next page on how to do more, but I'm going to wrap up since the music just kicked on. Sorry, y'all. Have a great day.